This lesson is about solving right triangles using tangent, sine, and cosine. Again, solving a right triangle means finding all unknown sides and angles. So let's look at problem number 1. Okay, let's get the easiest part out of the way, angle P over here. If I want to find the measure of angle P, I'm going to do 90 minus 53 because this is 53. So that means that angle P is going to be 37 degrees. Okay, so that's one of the three things I need to find. Now I need to find P and Q. Let's start with P. Okay, so to find P, look, these are the two things that were given, the 53 and the 30, and this is the thing that we're trying to find. So I have to look at the 30 and the P, and I realize that the 30 is the hypotenuse and the P is the adjacent leg. Okay, so I've got hypotenuse and adjacent. So that is the cosine function. So I should be doing cosine of 53 is equal to P over 30. So let's multiply both sides by 30. That way these are going to cancel out. So that gives me that P is 30 cosine 53. So that's 18.1. Wow, okay, that's a little confusing because we have capital P is the angle and then lowercase p is the side. I wish they didn't do that. Anyway, so that's two of the three things we need. Now we still need to find Q. So I have to sort of start over a little bit. Forget about that adjacent piece. And now I'm going to look at this Q. So I've still got the 30 still with the hypotenuse, but now this Q is the opposite leg. So I've got opposite and hypotenuse. So that's going to be my sine function. So that's going to be sine 53 is equal to Q over 30. But, you know, same basic concept. Multiply by 30 on both sides. So those are going to cancel out. So that's going to give me that Q equals, and in my calculator I just do 30 sine 53. So that's 24.0. Alright, so those are the three things. And it'll always be three things when you're solving a triangle like this. Okay, so moving on to number 2. Let's see what the three things are this time. Look, we're not given any angles other than 90 degrees. That tells me I'm going to probably wind up using inverse trig functions. So let's go ahead and find angle A right now. So looking at my angle A, and I've got the 80 and the 89. Which trig function is this? Well, the 80 is the adjacent leg. Well, why isn't 89 the adjacent leg? Because isn't that equally close? Well, the 89 is your hypotenuse. That's why the hypotenuse is different. So the trig function, I've got adjacent and hypotenuse, so that's going to be the cosine function. So I should be doing cosine of the angle. Now I don't know how many degrees this is, so I just have to call it A. So cosine of A equals adjacent over hypotenuse. So that's 80 over 89. Notice how you show your work. You have to show these steps. You cannot skip directly to the inverse trig function step. You have to write this down first. And then you can go ahead and put, okay, so A is going to equal the inverse cosine, and that's how you write that, of 80 over 89. You must show this step and then this step and then put your answer. So it's always going to be like boom, boom, boom. Initial problem, you switch it up, and then you write your answer. And that's 26.0 degrees. So that is the measure of angle A. Okay, let's find the measure of angle B next. So the way to find the measure of angle B is just to do 90 minus 26, because we just found angle A, to subtract from 90. So that's why angle B is going to be 64.0 degrees. So we have angle A, and now we have angle B. So that's two of the three things. We still need one more thing. We need to find side A. Okay, so let's do that. So if I want to find side A now, okay, so here's side A over here. Now, I could have used the 26 degrees and done, tangent or the sine function and gotten that, but you really do not want to use the 26 or the 64. You don't want to use something that you just found to find something else, because if you get the first thing wrong, then you're going to get everything wrong. So what's another way I could do this? How could I find A without using either of these angles that I just already found? Hopefully you remember that the Pythagorean theorem is what you do. Anytime I give you two sides, you will find the third side using the Pythagorean theorem. A squared plus B squared equals C squared. So literally we're going to do A squared, okay, because that's A, plus, and B squared will be 80, and my C squared is going to be 89 squared. The hypotenuse always goes by itself, so that's why it had to be this way. I could turn these into regular numbers, but I'm going to leave it like it is for right now and just subtract 80 squared from both sides. So minus 80 squared minus 80 squared. So that's going to give me A squared equals 89 squared minus 80 squared. Then I take the square root. Okay, if I take the square root of both sides, that's going to give me A equals 39. Okay, so those are the three things that I needed right there. Number 3, to find angle D. Again, I'm just going to do 90 minus 31, so that's going to be 59. So angle D is equal to 59 degrees. All right, 1 down, 2 to go. Okay, now I just need to find E and F. I think I'll find E first. So look, I've got the 31 degrees, and I've got the 8, and then I'm trying to find E. So those are the three things I'm going to focus on right now. Well, 8 is the adjacent leg, and the E is the opposite leg. Okay, because F would have been the hypotenuse. So E is opposite leg, and 8 is the adjacent leg. So that's the tangent function. So let's set that up. So we're going to be doing tangent. I know the angle, so that's 31, is equal to E over 8. So that's E over 8. So if I want to get E by itself, I'm just going to multiply both sides by 8, like this. Times 8 times 8. That way these 8s are going to cancel out. And that is going to go ahead and give me that E equals, and I'm just going to put 8 tan 31 in my calculator, and that is 4.8. Okay, so that is E. So now I have angle D and I have side E. So now I need to do side F. All right, so let me start this over a little bit. Okay, so I've still got this 31-degree angle. I've still got the 8 as before, but this time I'm going to try to find side F. Okay, you know that 8 is the adjacent leg still. We won't be needing that. But F is the hypotenuse. So I've got the adjacent leg and I've got the hypotenuse. Well, that's the cosine function. So let's go ahead and set that up. So that's going to be the cosine of 31, okay, is equal to adjacent over hypotenuse. So that's going to be 8 over F. All right, so what do you do when you have the variable in the denominator like this? Well, that is when you reverse this. Put the F out here, put the cosine 31 down there. So this is going to become F equals 8 over cosine 31. And then I could just put that in my calculator, and I get 9.3. All right, so those are the three things I needed to find: angle D, side E, and side F. Done. All right, number 4. What are the three things we need to find? Well, this time they're not clearly labeled, but I do need to find angle Z, which will be the easiest, because I'm just going to do 90 minus the first angle, which is 27.5. So that tells me that angle Z is equal to 62.5 degrees. Okay, so that's the measure of angle Z. So I also need to find these two sides. So I think I will go ahead and find XY next. So here is side XY. Okay, so look, this is what I have. I have this angle, I have side XY that I'm looking for, but I also have this 8.2. So these are the three things I'm going to look at to decide which function it's going to be. Are either one of these the hypotenuse? No. This 8.2 is opposite, and the XY is adjacent. Okay, so this is opposite, and this is adjacent. So opposite and adjacent, that's the tangent function. All right, so I'm going to go ahead and do tangent of 27.5, okay, is equal to opposite over adjacent. So that's 8.2 over XY. Okay, because that's side XY. Again, the variable is in the denominator, so I'm going to do this reversal. So that's going to give me that side XY is equal to 8.2 over tangent 27.5. And I can just put that in my calculator, and that is 15.8. All right, so that is side XY. I also need to find side XZ. All right, so for that, I'm going to sort of start over a little bit. Okay, let me get this out of my way as well. Okay, so side XZ, all right, I'll go back to red. So here's side XZ. I'll just put XZ on there. So here again, I've still got my angle. Now I've got my XZ that I'm looking for, and I've still got my 8.2. So 8.2 is opposite of the angle, and of course XZ is the hypotenuse. So we've got, this is opposite and this is hypotenuse. Opposite and hypotenuse, that is the sine function. So that's why we will do sine 27.5 is equal to 8.2 over xz. Okay, opposite over hypotenuse. Once again, the variable is in the denominator, so I need to reverse this. So this is going to become xz equals 8.2 over sine 27.5. I'm just going to put this in my calculator. Okay, so xz is equal to 17.8. Alright, so those are the three things I had to find for this problem. Alright, number 5. A sonar operator on a ship detects a submarine at a distance of 400 meters at an angle of depression of 35 degrees. How deep is the submarine? Well, which line in this triangle would be the depth of the submarine? Well, that would be this right here. Okay, this vertical line is the depth of the submarine. So we're trying to find basically this x right here. So, considering that we've got ourselves the 35 degrees and we've got the 400 and we're trying to find x, which trig function are we going to use? Are either one of these the hypotenuse? Yeah. This is the hypotenuse, the 400. This is the opposite leg. Alright, so from the 35, we've got opposite and hypotenuse. What function is that? Well, that is the sine function. So we should be setting that up. So sine of 35 degrees is equal to opposite over hypotenuse. So x over 400. How will we solve this, you ask? Let's just multiply both sides by 400. That way these 400s will cancel each other out. And that will get x by itself. So x equals 400 sine 35. I'm just going to put that in my calculator. That is 229.4 meters. Don't forget your units. So that's it. We were just supposed to find the depth of the submarine, and that's how you do it. All right, what's next? Number 6. Two buildings are 60 feet apart. All right, that's important because it's not shown in the picture. So sometimes you do have to read. All right, 60 feet apart. That's this distance right down here. All right, so this is 60 feet from building to building, which, you know, also would be this up here, obviously. Okay, so keep that in mind. A person at the top of the shorter building finds an angle of elevation of 20 degrees. Well, that's shown right here. And an angle of depression of 35 degrees if you look to the bottom of the building. So that's shown in the picture. How tall is the taller building? Okay, so we are trying to find the height of the taller building. So we're trying to find this distance over here. All right, that's the overall height of the building. Okay, I mean, I could call it h or something if I wanted to, but the bottom line is the height of the building is made up of two little pieces. one of those I'll just call X, all right, which is this part, and then the other one I will call Y. So if I find both of these pieces and add them together, that will be the height of the building. So the height of the building is going to be X plus Y. So we're just going to find X and Y and then add. So let's do that. So let's just take one triangle at a time and solve. So it's like two separate problems. Okay, look at this top triangle first. So I'm going to pull that off to the side. So looking at this top triangle, all right, this is 20, and we're trying to find X, and we also know that this is 60. All right, remember that they're 60 apart. This is 60. So it's just a matter of solving this triangle. Well, which trig function is this going to be? Opposite and adjacent. So this is the tangent function. So I'm just going to go, all right. Tangent of 20 is equal to opposite over adjacent. If I multiply both sides by 60, this, so then those cancel out. So that's going to give me that X is 60 tangent 20. Calculator, so that's going to be 21.8. Okay, wait, this is in feet, so X is 21.8 feet. So that's the first triangle. Now let's do the lower triangle. So the lower triangle is this right here. So let's just pull that off to the side for a moment. So looking at this triangle, we know that this is 35 degrees. Remember, this distance is 60. That's going to show up right here. And the Y that we're looking for is still this vertical piece. So let's see which function this is going to be. Well, guess what? It's still opposite and adjacent. So once again, it's going to be the tangent function. So we're going to do tangent of 35 is equal to opposite over adjacent. So Y over 60. So we'll just multiply both sides by 60, like so. 60, 60, just like we did before. So those are going to cancel each other out. So that's going to give me that Y is equal to, and I'm just going to put 60 tangent 35 into my calculator. So that is 42.0 feet. Okay, so X is 21.8, Y is 42.0. So the overall height of the building should be the sum of these two. Okay, so the height of the building should be X plus Y. All right, so that's just going to be 21.8 plus 42.0. So that's going to be 63.8 feet. All right, so that would be the overall height of the building. Okay, when a hockey player is 35 feet from the goal, he shoots the puck directly at the goal. Kapow! The angle of elevation at which the puck leaves the ice is 7 degrees. All right, so it drifts up at a 7-degree angle. The height of the goal is 4 feet. Will the player score a goal? Well, it's a matter of how high the puck will be. If it's over 4 feet, he's going to miss. So let's just draw a triangle to show what we're dealing with, it's got to draw it a little bigger than what they have shown there. Okay, so in my drawing, this is that 35 feet distance that they're talking about. So you can imagine that here's where the puck goes, and it's like shooting up in that direction. And you can imagine that the goal is over here somewhere. Okay, but we don't know if this will, if when the puck gets here, if it's going to be in the goal or above the goal. So we have to figure this out. So we need to figure out what x is, basically. They told us that the angle of elevation is 7 degrees. So we know that this angle right here is 7 degrees. So which function are we going to use? Well, the x is opposite, and the 35 is the adjacent leg, because this diagonal is the hypotenuse. So opposite and adjacent. That is the tangent function. So I'm going to do tangent of 7 degrees is equal to opposite over adjacent. So I'll solve this. That will tell me how high the puck will be. So multiply by 35 on both sides. So 35, 35. That way these will cancel out. X equals. So put 35 tangent 7 in your calculator. All right, so that is 4.3 feet. Okay, so that means this hockey puck is going to be a height of 4.3 feet by the time it gets over here. So this is 4.3 feet. But the goal is only 4 feet high. So that means if the goal here is only 4 feet high, and the puck is at 4.3 feet, it's a little too high. So the puck is going to go over the top of the goal. So will the player score a goal? Nope. Too high. Okay, 4.3 feet versus 4 feet. Okay, so that's number 7. Number 8, basically the same situation. Now we're 27 feet from the goal instead of 35 feet. The height of the goal is 4 feet. What is the maximum angle of elevation that he can shoot? So we've got this picture, but basically we're trying to find the angle this time. All right. So, you know, if we've got the angle here, which I'm just going to color that in. So, all right, so there's our angle. And then we've got this 4 feet over here, and we've got the 27 right here. Which trig function is this? Well, it's still the tangent function. 4 is opposite, 27 is the adjacent legs. So we will be doing this. Tangent of x, because we don't know what it is equal to opposite over adjacent. So that's 4 over 27. Fine. How do I find the unknown when it's the angle inside the function? Well, that's when I use the inverse trig function. So the angle is going to equal the inverse tangent of 4 over 27. And notice how you have to show your work. I must see tangent x equals 4 over 27, and then I must see x equals inverse tangent 4 over 27. You cannot skip either one of these steps. You can't even skip the x. I want to see x equals this. And then you can put x equals and put your answer. See how the equal signs and the x's kind of line up? X, x, x. All right, that shows the logical flow of the problem. Of course, this you just put in your calculator. So that is 8.4 degrees. So that will be the maximum angle of elevation that you could score a goal. Anything above that, you're going to go over 4 feet. Okay, I think that's it for this lesson.